Hi everyone, this is Ms. Deaver. Welcome to my online classroom, Algebra. This is Chapter 4, Lesson 5, Scatter Plots and Lines of Fit. Okay, in the past you have written linear equations given a point and the slope. Now what you'll do in this unit is investigate relationships between quantities by using points on a scatter plot. Use lines of fit to make and evaluate predictions. New vocabulary. Bivariate data is data with two variables. Scatter plot shows a relationship between two sets of data with two variables on a coordinate plane. A line of fit is when all the data comes close to the line graphed and is used as a trend line to make predictions. Linear interpolation is used to predict values inside the scatter plot, and we've talked about in the past linear extrapolation used to make predictions outside the data. Alright, so here's a concept summary of scatter plots, and this is really the basis of what I want you to get out of this lesson. I want you to be able to look at a scatter plot and simply say if it has a positive correlation. In other words, does one thing cause another? As x increases, y increases. As your independent variable increases, does your dependent variable increase? And in the first scatter plot, we see that that happens with a positive correlation. As x increases in the second scatter plot, notice that your dependent variable decreases. So it has a negative correlation. So when we're talking about relationships, we're really talking about that relationship between the independent and dependent variable. Notice in the last scatter plot there is no correlation. It would be difficult to say that your independent variable causes something to happen in your dependent variable. So that's no correlation. Alright, evaluate a correlation. The graph shows the number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. If there's a positive or negative correlation, describe its meaning in the situation. Well, the graph shows a negative correlation. And the way we know this is that for each year, more computers are in Maria's school, making the students per computer rate smaller. That means as the years increase, the number of computers per student is decreasing because they have to share more computers. So this would be a negative correlation. The graph shows the number of mail order prescriptions. Determine whether this graph shows a positive correlation, a negative correlation, or no correlation. If there's a positive or negative correlation, describe it. Well, I see as the years go by on mail order prescriptions that we have a definite increase in the number of prescriptions. So, for mail order prescriptions. And so that has to be a positive correlation. As the years increase or go by, then the number of prescriptions, mail order prescriptions increase. So let's read our options here. A, positive correlation with each year. The number of mail order prescriptions has increased. I agree, but I want to read all of my options because that's a good test strategy. Negative correlation with each year. The number of mail order prescriptions has decreased. No correlation or cannot be determined. Well, I definitely think it's a positive correlation. Alright, here's another key concept model, using a linear function to model data. First thing you want to do is make a scatter plot. Determine if there's any relationship that exists in the data. Draw a line in step 2 that seems to pass close to most of the points of the data. And when you're trying to make a trend line, what you want to do is try to split as many points on the bottom half of your line as on the top half of your line, so that you're not trying to hit as many points of data as possible. You're trying to split that data in half and have half of the data points plotted below the line and about half of the data points plotted above the line. And on step 3, you can choose any 2 points on the line of fit that you constructed to write an equation for the line. And you would use the slope formula, y2 minus y1 over x2 minus x1. And then you would use that line of fit to make predictions. Again, you could choose 1 point, and if you found the slope, you could use point-slope formula to solve it for an equation in y-intercept form. Alright, the table shows the world population growing at a rapid rate. Identify the independent and dependent variables, make a scatter plot, and determine what relationship, if any, exists in the data. Well, we know that time is always graphed on the x-axis, so we know the year is the dependent variable, and we know that the population is growing from 500 to 6,400 million, and so we see that as time goes by, as time increases or years go by, that your population increases, and so that would definitely make a positive relationship. So we're going to make a scatter plot. We're going to plot them. The independent variable is the year. The dependent variable is the population in millions. As years increase, the population increases. And there is a positive correlation between the two variables. And if I were making a line of fit for this, I have 1, 2, 3, 4, 5 points plotted. So I would probably make my line go through here, because I'm trying to make sure that I have 2 points on the bottom of that line, and then I actually have 2 on the top of that line. And so that probably would make a good split, and then I might use this point to solve it and make an equation. Alright, so draw a line of fit. Alright, they drew it with 2 on the bottom, and they drew it through that one with 1 on the top. So a line of best fit, you know, that's pretty subjective sometimes, unless you're using a computer program, which is what we're going to do with Barbie Bungee Jump. No one line will pass through all of the data points. So you want to draw a line that passes close to the points. So I can see this one. I can also see my version. That would be, I'm going to draw mine on top of theirs. That would be through this point. It's close to the points as I can. I guess you're trying to get to as close as many points as possible, or that's what they're trying to do. Alright, write the slope-intercept form of an equation for the line of fit. So we're using 2 points, a line of fit shown that passes through the points. Find a slope, use that slope formula. Alright. The next thing you want to do once you get that slope is use that in point-slope form or slope-intercept form to write an equation of line of fit. I use point-slope. That will help me solve for B. Put 1,000 in the place, and we're using the point when x is 1,850, y is 1,000. And you get approximately 35.1 times x minus 63,870. So that would be the equation of the line. Alright, the table shows the number of bachelor's degrees received since 1988. Draw a scatter plot and determine what relationship exists, if any, in the data. The years since 1988, bachelor's degrees received in thousands. Is it A, is there a positive correlation between the two variables? And again, we have to determine which one is the independent and dependent variable. B, is there a negative correlation between the two variables? C, is there no correlation between the two variables? Or D, can it not be determined? Alright, let's take a look at the table. Well, we have years since 1988, and it goes from 2, 4, 6, 8, 10. So I know that the years are going up in value. And I see that it starts out with 1,051, and this unit of measurement is in thousands. So we have 1,051 thousandths of degrees in 2 years since 1988, and I can see it's going up in value through year 10. So that's a positive correlation between the two variables. If I graph it, the years since 1988, I can see that as the years increase, the number of degrees increase. Draw a line of fit for the scatter plot. So if you're drawing a line of fit for the scatter plot, we know that the table started in around, let's see, 1,051. And we're looking for a positive correlation. Well, A is not a positive correlation. As the years increase, the number of degrees are going down. B is a positive correlation. As years increase, your degrees go up. In C, as years increase, you have the same number of degrees. That's not true from the table. And in D, you have what we call a piecewise function. As the years increase, it increased from 2 years to approximately 6 years. It fell off and went down between 6 and 8. The table doesn't support that. And then from 8 to 10 it increases again. So your answer has to be B. Write the slope-intercept form for an equation of the line of fit. Now, where do we get the y-intercept from? Let's go back. I want to go back a slide. Let me see if I can do that. Where do we see that y-intercept? If you're writing an equation from the graph, you might could look right there since we know B is the answer. And you could also look in the table and you could see what that might be. You could also use 1 point on the line. If I used 1 point on the line, could I not put it into point slope form and then solve it for the equation? So when you I want you to take a minute and I want you to try to solve this. I want you to pick 2 points on the line, use the slope formula, find the slope, and then use 1 point on the graph, on the line. You may have to go back a slide. And put it into point slope form and solve it for A, B, C, or D. Okay, I hope you got D. All right, the table and the graph show the world population growing at a rapid rate. Use the equation y equals 35.1x minus 63,870 to predict the world's population in 2025. Well, we know that 2025 is an x value. That's time. So if I take 2025 and put it in the place of this x right here, I should be able to find and predict the world's population in 2025. Evaluate the function when x is 2025. Put 2025 in the place of x, multiply it, subtract 63,870, and you get 7,207.5 thousandths. Millions, sorry. So in 2025, the population will be about 7,207.5 million people. It's a lot of folks. All right, the table in the graph shows the number of bachelor's degrees received since 1988. Okay. So we see since the years have gone by, it's a positive correlation. Use this equation, y equals 8x plus 1,104, where x is the years since 1988 and y is the number of bachelor's degrees in thousands, to predict the number of bachelor's degrees that will be received in 2015. Okay, so use your equation. How many years has it been since 1988? And we're going to solve it for y to find out how many degrees. So I would take 2015, subtract 1988, and I get 27 years. So let's just see if this works. Let's do y equals 8 times 27 years, because it's the years since 1988, and we want to predict the number of bachelor's degrees that will be received in 2015. I get 8 times and I believe D is going to be our answer. No, I looked at that wrong. I have y equals 1,320. So that's not D, that's A. Yeah. Okay, that was a short video, but all I really want you to get out of that is that positive, negative, or no correlation, and then we'll learn a lot more and apply a lot of what we know when we do Barbie Bungee Jump. All right, have a great day.